Today I'm going to be talking about molarity, which is how a chemist will calculate the concentration of a solution. And a solution is defined as a mixture of two or more substances, usually two. And for the sake of talking about molarity in solutions, I'm only going to be talking about solutions with two substances in them. And in solutions there are two main components. A solute, which is the substance present in a smaller amount. So if you have two substances, whatever there is less of, that will be the solute. And then the solvent is the substance present in a larger amount. And salt water is a perfect example of a solution. Just put some salt in a glass of water. The salt in that case would be the solute, and the water would be the solvent. And we use solutions when talking about molarity, because molarity is how we calculate the concentration of a particular solution. And the concentration is how crowded something is. So the more molecules we have in a particular substance, the more crowded that substance is, and the higher the concentration will be. For instance, 6 molar HCl, hydrochloric acid, will contain 6 moles of HCl for every liter of solution. 8 molar HCl, higher concentration, would contain 8 moles of HCl per liter of solution. The more moles, the higher the concentration, the bigger the molarity. And in this case, the HCl would be the solute, and water would be our solvent. Water is almost always the solvent in regards to in chemistry, anyway. And this is the formula for molarity, which is just molarity equals moles of your solute over the total number of liters of solution. So if we were in the laboratory and wanted to, for example, prepare a 3 molar NaOH solution, sodium hydroxide, we would first add 3 moles of NaOH to a flask, or any container really, but if you're doing it in the laboratory, you'll probably be adding it to a flask. And then fill the flask up to the 1 liter mark with water, and then simply mix until dissolved. You'll have 3 moles of NaOH for 1 liter of water, 3 molar NaOH. And so now that we know what molarity is and how we prepare a solution of a certain molarity in the laboratory, let's do the math. So a scientist pours 6.0 moles of H2SO4 into an Erlenmeyer flask containing 3 liters of water. What is the molarity of the resulting solution? Well, we simply plug the numbers that we've been given into our formula. We know that we have 6 moles of our H2SO4, that would be our solute. So plug that number in for the moles of solute up here. We have 3 liters of water, so 3 liters of solution down here. 6 divided by 3 is equal to 2. So the molarity of our resulting solution would be 2 molar. And here's another example for you. A chemist has a 4.5 molar solution of Na2CO3 in his laboratory. He measures that there is 2.5 liters of this solution. How many moles of Na2CO3 were put in the solution? Now this is a little different because you've been given the molarity and now you need to calculate the number of moles. But again, same as before, we just use the formula. We know we have the molarity is 4.5, so plug that in on the left side here for the molarity. We have 2.5 liters of solution, so plug that in here. And using our basic algebra skills, we would just solve for the moles of solute by multiplying 2.5 and 4.5, and that will give us, using significant digits, 11.3 moles. That's our answer. We're right. We're awesome. We're a genius. We're geniuses. Excuse me. And this is a handy way of calculating molarity, if you ever get confused, called the molarity triangle. Basically, you take whatever you're solving for. So let's just say I'm solving for moles of solute, and I'll cover up moles of solute with my hand, and I'll simply look. Moles of solute is equal to molarity times liters of solution. Since they're next to each other, I know that it's molarity times liters. If I have to solve for the molarity, I cover up molarity with my hand, and I see that moles of solute is over liters of solution. Moles of solute over liters of solution, or moles divided by liters. And I can do the same thing. I cover up liters of solution. Ooh, liters is spelled wrong. Whoopsie. And I cover up liters with my hand. and I see that it's liters is equal to moles over molarity. So just a handy triangle to keep in mind if you're ever confused as to what the formula actually is. That's molarity. Hope you enjoyed it.